around co-curricular activities and work for yourself. We're a little bit lighter on than the number of RSVPs we had, but this will mean it will be a very intimate and personalised session, won't it, Judi?
It will.
Yes. I know most of you have met Judi when you arrived, but it is my privilege to introduce Dr. Judi Newman, who is an expert in the field of education, psychology, and neuroscience, and we have been working with Judi. I've been working with Judi for almost 10 years now, in my previous roles as Deputy Principal and Head of Special Education in the state system before coming to Girls Grammar. And I think this evolved from me bringing that passion and understanding into the Deputy Principal student's role, looking after wellbeing, pastoral care, understanding that we are all diverse, very different, unique, and how important understanding of the brain is not just for us working with students, but for us working with each other as colleagues as well, and how we connect. I'm very relational, so that aspect of connection being the basis of human need and learning is where Judi comes in terms of the work that we've been doing for a number of years now, with the training that Judi's delivered to our teachers and teacher aides and boarding supervisors to help with fostering that connection and understanding of how we're communicating and helping our students be learning ready. So this has been implemented in this Brainwise program, has been implemented as part of our pastoral care program over the last year and a half, and through the work that we've been doing with Judi, we are now an accredited Brainwise school, which I'm sure Judi will obviously talk a lot more about today, and how important that is, that understanding of neuroscience for learning for our girls. Over to you, Judi.
Thanks, Cara. Thank you. I love coming here because most of my work is across Australia, and I fly in and out and live in Emu Park and Canada and the States. So to work with Cara just in my backyard is wonderful. I can even sleep in. Very nice. Okay, all right. So tonight I thought, what can I do in an hour? And it's not the first time I've been asked to do a keynote for parents and carers. And I usually, depending on the school, look at what would be helpful in regard to learning, so how we learn, because the science has showed us exactly what's happening in the brain by brain scans. How is the teenage brain different? I know that we're P to 12, but if I covered the whole age span, we would be here for a couple of hours. So tonight we'll just dip into the teenage brain and a little bit around how girls are different to boys and the way they think. So is that okay? So as Cara said, I'm a former high school principal. My last school was actually North Rocky High School. Now I'm an independent consultant and I work with the universities, principals and CEOs, the military, the police, on influence. That's my thesis, my research. So how do you get people to do what you want them to do? And there's two pathways there. To understand influence, you need to understand how we think, learn and remember. So that takes me down the learning pathway. And the other pathway, of course, is leadership, working with strengthening leadership impact. So tonight, we're just going to do a little part of that. So let's start with some underpinning principles of applied neuroscience. And don't worry, it's not going to be too heavy. And I've tried to select some topics that will be helpful so that we can put our parent lens on, but you can put your own learning lens on. Some of you may be teachers or lawyers. You can almost put, that's why I love applied neuroscience, you can put any lens on. It's so helpful. And it's about an understanding of the brain. It makes it easier for us to understand how people tick, what motivates them, and how do you influence them, and what factors are involved in learning uptake. So one of the fundamental principles that I tell teachers to let students know is IQ is not set at birth. We used to actually teach that. I'm old enough to remember that at university, when I went to university way back, my first degree, we were taught that. It's definitely not set at birth. Yes, we have traits, and those traits are either maximised or minimised with the learning and the experiences that we choose to have. But our intelligence can be grown by exercising our intelligence. And it can grow until you die, unless you get dementia or have another neuro disease that actually takes away that capacity. Everyone can get smarter as they get older. And we'll have a look at that. I think of it as cow paths. So when we're learning something new, we have very little neural pathways in our brain to support that new learning. So it feels uncomfortable and sketchy. But as we repeat that learning over time, so as your sons and daughters, imagine some of you got sons too, I know it's a girls' school, repeat that learning, those dirt tracks become superhighways until it's hardwired. And it's called spaced recall. To learn anything and to consolidate it to long-term memory, you actually need sleep learning recall over time. So we shouldn't overemphasise instant memory because most people don't learn that way. The second thing is that when we think, we fire a neuron, and when we learn, we wire them. It's called Hebb's law. And that's why I hear teachers say sometimes, look, I taught it. They know it. We talked about it. They understood it. But in the exam, they couldn't do it. It's because thinking's different to learning. You can think about something and understand it in the moment, but unless you practice it and repeat it and recall it, you forget most of it. So teachers need to understand that learning takes time and we shouldn't be cramming for exams. So, you know, that's your argument with your child when they're cramming at exam time. There is limited learning and behaviour change without neuroplastic changes over time. So the neuroplastic changes are electrical, chemical and physical. So the 86 billion neurons that you have in your brain, they actually grow. They grow dendrites and spines. And in fact, you can grow a spine in 15 minutes of effortful learning, so by focusing. That's how quick it is. And then over time, that spaced recall, you're going to grow more dendrites, which is your grey matter. Your axons and your dendrites are your grey matter. And then as you repeat that learning, you grow more white matter, which is your myelin. And the more myelin a child has, or an adult has in their brain, the faster you're thinking, the more efficient you're learning. So you can be growing more grey matter and white matter over time as the years progress, with just practice. And it doesn't matter what you're learning. The other underpinning applied neuroscience principle is the more neural chains you have in the long-term memory, the less cognitive load you'll be on when you learn something new. You know that feeling you get, you're full when you're learning something new or you don't understand? That reduces the more you know. So the more you learn, the more you can learn, because your brain lays down what's called schemas. And schemas are simply neural chains. They're a concept. So a dog has 4 legs, that's a schema. The more schemas you have, the smarter you're going to be and the more connections you can make very quickly. So I tell students, read. And it doesn't matter what they read. If they're a slow reader, then get them something that's, that they're interested in. Even comics are better than nothing. Read, 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 because the more we read, the more schemas we develop. Because it helps us with an understanding of the world, doesn't it? So another underpinning principle before we move on is the brain chunks data. It loves to chunk, and the more expert brain you have, the bigger the chunks are. So the more chunks you have. And if I showed you that list of letters, I'll show you again and ask you to remember them in 5 seconds in order. Really hard, isn't it? But if I chunk that as your brain does, I could give you 3 seconds and you would remember them and you'd be able to tell me. Anyone want to guess how I'd do that? What were they? Alphabet, yeah. So the brain, as soon as it chunks something, those chunks are really hard to break. Once you remember something, it's really hard to forget. So chunking is really important. And it's something that students can do as a memory technique as well. Acronyms are chunks. So there's a neuron. And when we talk about neuroplastic changes, when you learn, that's what we're talking about. Those dendrites look like tree branches, don't they? And the myelin is the white matter, a little coat around the axon. And that's what we grow more of. More white matter, more grey matter. The more white matter, grey matter you have, the higher your IQ, the more you can learn, and the less cognitive load you'll be on when you're learning something new. And teachers have ways to, strategies in place to actually take advantage of that. And this is why I tell students, don't Google everything. Google is a fantastic tool. AI is a fantastic tool. It's not going to go away, so embrace it. However, don't learn all your essential knowledges like that. Because as soon as you Google everything, your brain will drop it a month later because there's no effort. There's no neuroplastic changes. Because to actually grow a dendrite or thicken that myelin takes effort, takes energy. This is like, Google is like learning on a silver platter. It's convenient, but it's not the right strategy for learning essentials, especially if you have to recall them in an exam coming up or an oral. Or if it's an essential knowledge for life. You know, you want to remember that. We first saw that we grow more grey matter in a study done in the year actually 2000. This is the first study where they found that our hippocampus was thicker with what we learnt. So they studied taxi drivers, you know, that actually drive those black formal taxis in London, and they have to know every street and laneway, you know, in inner London. What happens when London Bridge falls down, and name 3 other ways to get to Buckingham Palace, for example. What's happening in the seasons? Compared to the brain scans of bus drivers that went from A to B and they didn't even have to think. For 15 years, you know, they just went down the one pathway from A to B. The size of the hippocampus, which is to do with your navigation and processing your short-term memory into long-term memory, was significant. So the taxi drivers had built their IQ by putting in effort, concentrating, focus. So we need to let our children know that talent can be grown. You can be an ordinary person. You don't have to be extraordinary to be an Australian champion in anything, whether it's knowledge, tennis, university, you know, topping your class or doing well in your class, being the best hairdresser and knowing your stuff. Talent can be grown. And there are so many studies that show that it's not the actual traits, it's the practice. And the difference between the novice brain, so someone who doesn't know much when they're starting to learn something, and the expert brain after 10 years or 10,000 hours. 10,000 hours is the theory, but you know, it's not a perfect science. But years later of practicing and that spaced recall of growing that white and grey matter, there's the difference. So I won't read that, but there's a significant difference in the brain scans when we look at the scans comparing a novice brain that's just started playing the violin or learning about physics compared to an expert brain that's now a professor of physics at a university and a national champion tennis player. Very different brains. But we can control that. So building students' self-belief is really important because they can be anything they want to be within reason. I teach teenagers and encourage teachers to teach teenagers cognitive bias because in the world we live in of misinformation and disinformation, they need to know that a cognitive bias is a distorted truth, and you may not even know you're wearing that lens. There's about 400 cognitive biases, and I have a lot of fun with teachers testing their cognitive bias and what that looks like, and knowing that your belief system is simply a neural pathway. That's why we have different religions and everyone thinks they're right. That's why we have different politics and everyone thinks they're right. It's just a belief system, neural pathway that we've created. People can change their mind and change their belief. They're socially constructed, they're learnt behaviours. They're not innate. You're not born a particular political persuasion, are we? So the difference between a schema and a cognitive bias. A schema is simply a concept. A dog has 4 legs. So say I'm a 2-year-old and I'm just learning schemas and I've just learnt how to recognise a dog. That's a schema. So I've learnt that a dog is fluffy, has a tail and 4 legs. I go to the zoo with my mum tomorrow and I spot a tiger, and as the 2-year-old will go, dog. And his mum will go, no. That, yes, you're right, that has 4 legs, fur and a tail, you're right, but that's a tiger, and explains why that's a tiger, the difference. So you update your schemas all the time. If it's a cognitive bias, you won't even know that what you're looking through is distorted. So explore them for yourself. You probably already know some things, like probably the one that comes up all the time is confirmation bias. When you believe in something, you only see supporting evidence to support that belief. You don't see anything else. That's called a confirmation bias. And a heuristic, I've thrown that in there because sometimes someone from the audience says, well, what's the difference between a cognitive bias and a heuristic? Heuristic is a psychological term and it's a simple rule, a rule of thumb. But a rule can be very easily changed. For example, I don't trust anyone that has, someone gave it to me the other day. She said, I don't trust anyone with a moustache. Well, that's her heuristic, that's her rule. But of course that's not always right. So really interesting to look at cognitive bias. Okay, if I asked you, what are the 3 ingredients that fire has to keep the fire going? What would it be? It's not a trick question, and it doesn't matter if you don't know. Just guess. What does fire need?
Fuel.
Yep, fuel, oxygen and heat. Okay, ignition, heat. If you took one of those away, the fire would go out. What are the 3 things that we need to learn? If we took one away, there would be no learning. That child couldn't learn. What would they be? Just guess, it's okay.
Curiosity.
Yeah, curiosity is a good one.
Environment.
Yep. Certain things in the environment, yep. So teachers need to know what they are, okay? And I thought I'd just share them with you. There they are there. So we need downtime. After you learn something, we need downtime to make sure that your brain can process and encode that data to long-term memory. That's processing time. We need a brain breaker for on cognitive load. You know when you can't think anymore? Your brain's full, your short-term memory fills up really quickly and you're on cognitive load very quickly. A brain break is simply 2 to 10 minutes of anything that's joyful that doesn't involve new learning. And you can have a brain break, you know, when you're on cognitive load. And it looks after your brain too, it needs that break. Your brain did not evolve, where it wasn't designed to constantly process continuous new information. And there's so much information coming in now. And in fact, Dr. Judi Willis, a medical doctor and neuroscientist, says that for the first time ever, the teenage brain has too much coming in to it for it to process. And we see more anxiety and depression in our teenagers. So the third one's sleep. Teenagers need sleep. Children need sleep. In fact, they're thinking now the teenagers need more sleep than children. Recall, you need to be able to recall, retrieve it, to remember it. Every time you recall, you relearn. Visiting that learning material once doesn't work. Not many geniuses in the world, okay? Most of us have to work hard at it. Repetition, putting effort in, takes effort. Emotion makes the memory stick because it keeps us curious, interested and motivated. That's where the emotion comes in. Error detection. Without error detection, you're not learning the right thing. You know, practice doesn't make perfect, it makes permanent. Once those neural branches are made, you can't break them. Not initially. By not using them, they will actually erode. But you consciously can't break them. So it is permanent. Application, if you can't apply it or use it, you don't know it. Attention, if you're not paying attention and focusing on it, you won't remember it. You only remember what you pay attention to. Meaning, it has to be relevant. So you make those connections. And modality, meaning teach it in different ways, learn it in different ways, read it, speak it, draw it, do it, question it, debate it. So they are the ingredients I thought I'd just share with you because the teachers here know and are attending to that in the classroom. So learning is anything that happens inside the brain. Teaching is anything that happens outside the brain. So we can no longer say, I've taught it so they know it. Can we? We have to check for understanding. We also need to know that stress inhibits learning and creativity and innovation. When you're stressed, the lower regions of your brain are active and messages simply can't get through to your prefrontal cortex. Your prefrontal cortex is where all of those things happen. So planning, prioritising, most of your personality, your empathy, being able to put a brake on your negative emotions. You know, I'm not going to hit them because I'm frustrated. Being able to put a brake on that. That's your prefrontal cortex. Problem solving, higher order thinking, critical thinking. All the things that keep you out of jail, basically. So when you're really stressed, that part of your brain is not working properly. And if you're a child or a teenager, that risk doubles. The back of your brain is more emotional. So your prefrontal cortex, when you're a teenager, from around 11 to around 17, is what I call offline, sometimes. A teenager can be just as mature as an adult sometimes, but when their prefrontal cortex is offline, they really can't access their prefrontal cortex with that rational, logical thought. They're working on feeling mode. You know, if a grade 9 student makes a mistake and you think, why would you do something so silly? And you'll say, what were you thinking? And they'll just look at you because they weren't thinking. They can't think. They were actually just operating on the back of their head. So sometimes the parent and the teacher needs to be their prefrontal cortex, and you need to pick up that. And it's not because they're lazy or naughty, it's simply biology. They're going to have times like that. And this is why we ask 45 to 65-year-olds to be the Prime Minister of a country, you know, to do those complex big tasks, because the amount of myelin that you have accumulated around an expertise at that age is significantly more than any other time in your life. So you're much more expert at something between 45 and 65, much more mature. Does that make sense? So if you're going to write a book or you're going to run a large company, we need maturity around that. We don't put a grade 9 girl or boy in charge of $1 million house when we go away from a weekend, even if they're a good kid. And this is why. Sorry.
After they get to 65, do they start losing?
Yeah, we do, unfortunately.
Yeah.
Your memory starts to just dwindle a little bit after 45.
Yeah.
Your white matter is permanent. Once you hit 65, it starts to, things start to break down a little bit more. Yeah. And everyone's different, of course. Yeah. And even children, I find, are different. Like, I can remember the number of times where a primary school principal said to me, I was a secondary school principal, the primary school principal down the road had said to me, I've said, you know, oh, my school captains are just so lovely. And they would say, you know, they were lovely in grade 1. They're just a mature kid. So there are those traits in place, and we're all different. But we certainly can all get there. So this is a very simple graph just to show you that if you look at the blue line, the limbic system, that's the back of your brain. So your thalamus, your hypothalamus, your hippocampus, your amygdala, that's your limbic system. That's when you're running on stress and you're an emotional. That matures, look at that, age 12. Whereas your prefrontal cortex, where your reason and logic is, your problem solving is, which is your red, okay, it doesn't mature for boys until they're up to 32 years of age. And girls mature much quicker than boys, around 28. Again, it's not exact science, you know, it's means, statistically, but that prefrontal cortex is maturing for a long time. And in fact, some, particularly boys, never grow up. Okay? Hope you're not married to one. And it can be the other way around. I shouldn't pick on boys. That particularly grade 9 boys, the statistics will show that if they're going to go off the rails, it's around then. And it doesn't mean they won't come back on. You know, again, it's biology. It's not about being naughty. So this was just to emphasise that our teenagers are running on feeling.
What's a pruning dump?
Yeah, good question. So after we're born and around 11, we have a pruning dump. So those dendrites that are the branches in neurons, they're pruned. So they're cut. Because the difference between a child's brain, a teenage brain and an adult brain can be seen on the scans. And the brain literally rewires and prunes to prepare a child for adolescence, to prepare an adolescent for an adult. So you're refining your pathways constantly. So an adult brain has much less dendrites in certain pathways, and that's our maturity. Good question. Here's a little quiz. Why is the firstborn statistically, don't take it literally, more successful? And successful in this study was all the things you'd expect. Health, wealth, happiness, professions, own their own home. You know, there were markers, okay? But generally, what is it? A, B, C, D or E? What do you think?
C.
C? You'd be right. face-to-face time with one adult for the first 1,000 days of their life. So your brain, when you're a tiny baby, a newborn, for the first 1,000 days for that brain to mature and connect to the rest, the prefrontal cortex to develop and connect with the rest of the brain, needs that one-to-one blueprint, and they need language, and they need eye contact, and they need a calm, consistent, loving parent that keeps them safe, feeling safe. And there's all sorts of sad stories about the babies that don't get that. And that's why if you're first born, you're just lucky enough to have all that attention. That's all that means. Doesn't mean if you're number 3 or 6 that you're not going to be successful. Of course it doesn't. And it doesn't mean if you leave your newborn into care, it doesn't mean that they're not going to be successful. It's just showing you what the science says. If you're going to maximise that brain development, then one adult is helpful to be home. So there's the brain there. We don't need to learn those names today. But in the red, you'll see there are 3 areas. What I call the emotional brain, which is our lower regions, our social brain, and our thinking brain. So let's have a look at what the research says about what happens in an interaction between teacher and student, parent and child, leader and team member. It shows that we judge somebody in the first few seconds by their trustworthiness, their warmth, and their competence, their credibility. That's because those 3 factors align directly to neural networks in the brain, the 3 brains. So brain 1 is our emotional brain, and that's movement and breathing. So all reptiles have brain 1, and humans are hardwired to detect threat because they have brain 1, because your brain wants to keep you safe. It goes right back to the Stone Age of where our brain evolved from. Your brain is very much like the Stone Age brain. Your brain and my brain, not much has changed, but our whole environment has. So our brain thinks it's still living in that time. Sounds weird, I know, but true. There's so much research around to show that. And we need, therefore, to remember that negative emotions are going to be more likely, more common and longer lasting than positive ones, because we have 4 to 5 times the neural networks for negative emotions and positive emotion. So our brain tips to the negative. Think of the time where your best friend gave you hard critical feedback that you needed to hear, but you didn't want to hear. That's what you remember, not the 1,000 times that they've given you support. Our brain tips to the negative. And this has implications for leadership and learning. So leaders, parents, colleagues, we need to build trust, because your brain's first port of call is protection. We have a tendency to experience 2 brain states because of this. One is what I call agitate state, where your lower brain is active. When I say active, I mean the blood flow and electrical activity. And the other is what I call contribute state, is where you want your child to be in school and at home. That's where your prefrontal cortex is active. So that table just shows that it's completely different chemicals. Dopamine, oxytocin, serotonin is flowing freely, and noradrenaline in the contribute state, whereas cortisol and adrenaline is flowing freely in the agitate state. It's 3 completely different areas as well, and we have different emotions associated with it. So teachers know how to bring about contribute states, because while a child is in agitate state, they're not going to learn well. When a child makes a mistake at home and you have to pull the parenting out, then they're not going to be listening well if they're in agitate state. They need to cool down first. Because when we're in contribute state, we're more likely to solve problems, take on feedback, trust you, be optimistic, etc. When we're in agitate state, when the back of our brain is more active, we're more likely to push back, distrust, resist, be closed to learning and incurious. Reactive and defensive. So we need ways to change brain states at critical times, not just for the child to learn or the child to communicate and keep that, communication open with you as a parent, but also for yourself, for your own wellness. We need ways where we can be in contribute state, where we're relaxed and not stressed, confident and not defensive. Because while you're in that agitate state, cortisol is going to be flowing and it's not healthy. Cortisol is really hard to get rid of out of your system. Whereas dopamine, oxytocin, serotonin in contribute state, when you're feeling rested and content and confident, it's released very easily. Cortisol gets stuck. But there are ways to get rid of it. So brain 2 is our social brain. All mammals have a social brain. They can feel embarrassed, they can feel love, they can feel sad. And our brain evolved to belong to and operate in a group. So we need to build relationships. And that's, of course, how we tell teachers that relationships are really important. It's not just about teaching the content. It's about rapport building with that child. Your brain can't tell the difference between physical pain and emotional pain. So a broken arm looks very much the same in the brain scan as a broken heart. So we shouldn't underestimate, particularly for teenagers, when they feel heartbroken or embarrassed or alienated from their peer group. It hurts. And because they have what's called receptors, more receptors in the brain, they actually feel more deeply. That cut feels much more painful for them than it does for an adult. This is a brain scan of 2 3-year-old children. The one on the left is a normal child with a normal loving parent. The one on the right has been neglected socially and emotionally, was fed, but the brain shrinks and has lesions. So much so that that child will have developmental problems, will have learning problems, and sometimes they die. That's how important that emotional support and relationships and rapport and feeling safe and belonging to a group is. And that's why Cara talks about a strong sense of belonging being really important in a school community, because it's not just a well-being factor, it is a survival factor. In the archives of the London Museum, when I wrote my thesis, I found this study. There used to be an orphanage attached to the London Hospital, and they had an epidemic. And to protect those babies, they were all newborns, they were told, the staff, the nurses and the carers and the cleaners, to wear white coats, white gloves, full face masks, and not to touch the babies unless they were feeding them. All those babies died before they were 2. They were mystified to start with because they didn't have any symptoms of the epidemic. But now we know that their brain shrunk and they didn't get that rapport building, care, love. They felt unsafe and lonely and their brain shrunk and didn't develop. I'll let you read that there. So brain 3 is our thinking brain. Rational thought, remember, personality, empathy. We have an innate desire to learn and achieve. So I let teachers know, focus on motivational and confidence levels. Forget about IQ. Nearly every child is smart enough. We can grow our intelligence when they're interested and motivated. So build agency, build self-belief, build that self-efficacy in learning and in themselves. So how do you build and strengthen your prefrontal cortex? With novel learning experiences, travel, learning a different language, reading, learning a musical instrument, plus consistency, certainty and routines at home. That calmness. So far, brain 1 is associated with trust, brain 2 is associated with rapport, brain 3 is associated with growth. And you can't separate, because of that, you can't separate emotion from cognition. So thinking from feeling. How we think about someone is going to affect whether they're willing to engage or not with the parent or the teacher or their peer. So we tell teachers to calm the brainstem to build trust, make sure the child is learning ready, otherwise their amygdala is going to be overloaded and the messages simply won't get through. We need to engage the limbic system and build those relationships first. And once trust and rapport is built, then we'll see some growth. But until that child trusts their teacher and has a relationship with that teacher and their school community, and the same applies to any human, whether it be parent or a marriage or a child, there's not going to be a lot of growth. So let's have a look at the teenage brain. There's major construction going on. And remember, that's around your rational thought. So they're not always going to be online for problem solving, rational thought. I don't know whether you've has anyone here got a teenager? Okay. So I don't know whether you've noticed, but sometimes they're planning an organisation. Girls are better than boys though, usually. Remember, this is a generalisation because every child is different. Their ability to appreciate and to thank you for gratitude needs to be grown as well, usually, because they're quite self-focused teenagers until they become an adult and learn, that out of yourself, out of your own head, getting out of your own head. The myelin thickens, speeding up thinking, so they have increased memory capacity. They're just ripe for learning. The younger children, around 5 to 10, they are just learning at a rapid pace. They're like sponges, aren't they? Corpus callosum strengthens, so that's the connective tissue that connects their left and their right hemisphere of the brain. And they think that makes a teenager more likely to see the grey. They see the parent for the first time as a person, not mum and dad. It might be that they can mix in their communication, they're more likely to engage language with emotion. Particularly girls, boys aren't so hot at that. They have a pruning dump to get them ready for adulthood, which means they're going to be they can't think as well. It's a bit like their brain is closed for construction for a little while. Think of it like that. Sorry?
What age roughly is that?
11 to 16.
For girls?
Yeah, yes. But boys, because they mature later, it's longer for them. And depending on how mature the child is, sometimes it starts in primary school age. Yeah. But particularly around 14, there's a lot going on. And then you add the hormones and personality, styles and gender as well. So 17% reduction in grey matter to get them ready. Limited emotional regulation because the prefrontal cortex is closed. So they've got no handbrakes some days, sometimes, not all the time. They're egocentric and have a heightened sense of fairness. So arguing with them is really difficult. And they may be quite outspoken because they're developing their own moral compass. moving away from that family moral compass. You hope that they don't, but they're developing their own or confirming what you've already taught them. Makes decisions based on feeling, not logic, and they have increased peer pressure because they care what their peers think. They have more dopamine receptors, so they get a high from risky and funny behaviours. I used to take away the school ski trip of 16 and 17-year-olds and used to have the best time because they were so funny. They used to make me laugh out loud because of this. They have a heightened sense of comic. Seek rewards, so their risk behaviour heightens. And that thrilling experience feels fantastic because they have more receptors. So we have to create for them safe risk behaving spaces, don't we? They have delayed production of melatonin, so they find it really hard to get up in the morning and go to bed early. If that's happening, that's biology. Serotonin disruption, so they could be a tad moody some days. I'm sure you've noticed that. They feel more stress, more data than the prefrontal cortex can handle. Exams, school, teachers, homework, grades, expectations, the news on the TV, Facebook, etc. They've got a lot of data coming in. And they need to cut some of that somehow. That's a challenge. They have more cognitive load than any other teenager that's lived so far. So one of the strategies that is going to be really helpful, particularly for children over 5, is to teach them to regulate their emotion. There was a study in New Zealand carried out on 1,000 babies, and they followed them. It was a longitudinal study. They followed them until they were 45 years of age. So they must have gone through quite a few professors. And to read the results is fascinating. The one thing that they found that led to success in a lot of ways was emotional regulation. In other words, the adults that learnt from an early age that could regulate their emotion, stay composed and had strategies, did better in life. So when calm, teenagers can be just as in control as an adult, and their brain is sometimes offline. But if teenagers can learn to regulate their emotion, the cortisol can be kept at reasonable levels. But children in primary school need to be learning these emotional regulation skills too, and I know that grammar, Rockhampton Girls Grammar does that. And the teachers have been discussing ways to do that. Normalise ups and downs, because children and teenagers haven't lived like we've lived. They don't know that you can feel really bad 1 month or 1 year even, or 1 day, but you come out of it. Life is full of ups and downs. They think sometimes the risk is that when they feel really down, they think they'll never get up. So we have to teach them and normalise ups and downs. Teach conflict management. What do you do when you're angry with someone or you've been treated unfairly? And the school will do that too. Explicitly teach compassion, empathy, gratefulness, appreciation and kindness, because when we're a child and when we're a teenager, that part of our brain doesn't work very well. And for some adults it doesn't either, does it really, if we're honest? Okay, some of the immature adults. There's a country in one of the Scandinavian countries have just put in their curriculum where they're teaching, and it was particularly compassion and kindness. And they have the lowest bullying in schools in the world. So there's tests, where they actually measure that. But they're explicitly teaching, and now I know that the curriculum here teaches those wellness emotions, and that's a good thing. So what strengths do teenagers have? Well, they have a marked increase in memory capability, open to new experiences, at their peak in learning capacity, sharpened sense of comic, we said. They like to fit in and not stand out, and you can use that. They're interested in anything that relates to them. They begin to see the grey. Their abstract thinking improves, that metacognitive thinking. Recognise more emotions. I find that boys can't always name the emotion. Girls are a little bit better at it because they have more of an emotional language.
Is it just because of being taught that though?
I don't know. It's also because there would be that, because that's, learnt behaviours, and depending on what cultural background they've been brought up in. But their brain, the boy's brain, is there's more activity on the right-hand side, and the language, most of your language capacity is on the left-hand side, and they have less activity in their emotional side. So there's a little bit of that as well, of what's happening in the brain. So we can give them stimulating environments, and we've talked about that. I won't read those. The last one I will mention though, strong role models. They need an adult in their life. Boundaries and high expectations. I always say 1 scoop of challenge to 4 scoops of support. And when I say support, I mean encouragement, love, kindness. So we do need high expectations at school and at home, but it has to come with a lot of support. You may have noticed that teenagers don't do well with power. So forcing, nagging, interrogation, punishment, they don't work. Short term they might. So finding other ways to negotiate with them is important. And this is one, it's called empathetic inquiry. So we want to get up to level 5 and 6. So we might say, let's try 5. You've been trying for a month. That shows you're very resilient, Tim. You've always had that strength. Keep going. That's called championing the struggle. But the better one, and an even that has more impact, is empathetic exploration. So they come home and Julie is sad and upset. You must feel sad about that. I thought you might be upset, Julie. You said you were, and just repeat something that they've said and then go from there. So that is so much better to get a conversation going for problem solving and keeping your communications open with a teenager than actually all the other traditional ways.
Can you get a picture of that slide?
Yeah, of course. Yeah, you can have any slide you like. And this is another one that I call rewire, and teachers know this one. So, we can, in the old days, we used to lecture them, but it just doesn't work long term. And of course we suspend, and sometimes principals have to suspend because you want to move that behaviour away, and I say this from a former principal myself, away from the other 1,000 students. However, we know for that particular student, it doesn't really teach them alternative behaviours. So this is a conversation you might have. They've made an error, right? Their prefrontal cortex was closed for construction. They were offline, their brain was offline. And you might say to them, how did you react? So you know they've had a bit of a meltdown. How did you react? And they tell you. How did you feel about that? So you're showing empathy. Was that consequence helpful to you? Oh, no, I guess not. Now Martha's not talking to me. What is a better way to respond? So you're teaching other alternate better behaviours rather than giving them a slap. What are you going to do? Give them ownership rather than make them do something. And they're pretty good at this if you're not doing it while they're cranky. It might be even the next day. And how can I support that decision? So that's called a rewire conversation. And it's coaching, really. It's asking questions. So you're not actually telling, you're asking. Tone is 50%. Don't use a parent, child, or what I call a lollipop tone. So a parent tone is, they'll get defensive. A teacher tone is something else. We tell teachers, don't use a teacher tone. Don't get that tone in your voice. They'll pick it up. A lollipop tone is, good morning, how are you today? They hate that. Unless you've got preppies or something, that's different, okay? Unless you're, on the floor playing with toddlers. But a teenager's very sensitive to tone, so we talk about use pass the salt tone. And that's the same tone as you would use, that's warm and confident, that you would use at the dinner table when you say, may I have the salt, please? It's neutral. Role model. This is not new, is it? They may not be sensible and mature on every occasion. And teenagers need adults in their life. They need an adult champion. And uncles and aunties and family friends and teachers are really, a good part of that village. Don't assume they tell you everything. Now, you probably won't like me for it, but I could count 10 times where when I was principal, I've had a conversation with, it's usually a girl, a teenager, a 16-year-old, 15, 14-year-old, and they've told me what's going on, but when mum comes in, they say something else because they don't want to disappoint you. They don't want to, they don't want to get in trouble. Why would you? So where the mum said to me, oh, she tells me everything. That's not true. They won't tell you everything, not always. They're developing their own moral compass and their own self-identity, aren't they? Teenagers are information rich but experience poor. So they know a lot of stuff, they can look it up. But they don't live in the generation where you could go down the backyard creek and hop in the boat by yourself. But they're experience poor, so they're going to make errors. So 3 things that matter: relationships and sleep is a big one. So finally, the difference between a female brain and a male brain, I'll leave that with you. But there are some differences and that has implications, and I'm sure you've noticed quite a few if you've got both genders at home. But just keep in mind it's a generalisation, because the older you get and the more expert you become in something, and if you're a lawyer and you're expert at that, to actually at work you may be very similar to your peer, doesn't matter what gender they are. And I see it in leadership. Good leaders are good leaders no matter whether they're female or male. There's outstanding ones and ordinary ones, and lots in between. So gender, yeah, there is a difference, but not for everyone in every context. So I can leave you those slides. There's a few of them actually where this shows the gender differences. And just a handy strategy there for behaviour management for your child. The older they are, the better it works, where you say, Mum, can I go to that party? Or Dad, can I go to that party? Yes, you can, if Dad picks you up at 11 p.m, or if you go with your older brother, or if, so yes, but if works. Saying yes first lowers, gets them in contribute mode, lowers the defensive issues, but it puts your rules and boundaries on. Okay, there's some books there, you're very welcome to have a look. They're also on my website, and I'll give you these slides of other people that have written books about children learning and teenagers as well, that might be helpful. Thank you. Thanks for listening.